All right, guys. I said a minute ago, next week I'm going to try to get started as close to 6 as possible. So make sure you're in the classroom so that it's not just, one or two of us and then having to back up and review. It's a little bit tough of a time frame for me because I'm getting off of work at 5:30 and then coming straight here and, hopping on the computer. But we do want to try to make the most of our time, and I'm going to try to honor your time a little bit more by making sure we use the full 2 hours. And I'm glad that you joined us tonight. This is session number 5, and we've been doing some good work with looking at integers and word problems and getting into a little bit of pre-algebra and algebra. So tonight I wanted to kind of start bringing it all together, but also review specifically solving equations when they have a variable. Because when we started last time working on some of those word problems, we realized that it was a little bit too much information. So we're going to back up, make sure we have those basics, and then we're going to add a little bit of heat to it. So I wanted to start with a review of some of the terminology, because again, if you know what the question is asking, then you're going to be more likely to answer it to the best of your ability. If you don't know what it's asking, then you can't answer it. So first off, there's terminology variable. If something varies, what does that mean?
Like it's like the amount. I mean, the amount of something. Oh,
Yeah, it can be. Yeah. So variable comes from the same word as like variety or varies. It can change. It's something that you don't know necessarily what it is. So the variable in an equation is going to be your unknown number. And it is represented with a letter. Okay. Can y'all read that okay? Again, I ordered a webcam. Hopefully it'll be here tomorrow. Walmart said they'd be able to deliver it today, but apparently they were out of stock. All right. So an equation is the next term you want to know. If you look at the first few letters of it, EQUA, what word does that kind of look like?
equal.
Yeah, equal. And that's exactly what an equation is. It's a numerical showing or numerical statement of equal amounts. So, for example, an equation that has a variable might be, to make it really simple, 3 equals x. So that means if you see x written somewhere in that context, then the x is just a symbol that represents the number 3. So anytime you have a letter in a mathematical problem, it's just a placeholder. It is like a blank that you've got to fill in. And that's what we're going to be solving for, is that variable. Okay, so now that we know what those terms mean, the next step is knowing what to do with them, right? So we can make this little note: to solve for a variable, get the variable by itself. Like here, where you have x equals 3, you want to get it down to as simple as you can so that you know exactly what that letter represents. So to get the variable by itself, do the opposite operation of what's shown in the equation. So for example, if you have 3 equals x minus 5. We're trying to get that x by itself, right? So right now, x has a minus 5 next to it. So minus indicates subtraction. So what's the opposite of subtraction?
Adding.
Correct. So to get rid of it, we would do like we were doing yesterday, plus 5 over here, and the two 5s would cancel each other out. You'd have the positive 5 and the negative 5, which, you know, if you have 5 of something, you take 5 away, you have 0. So it cancels each other out. But this is extremely important. We're going to do a big note here. Note. What you do to one side, or what is done to one side, must be done to the other. So in that example, 3 equals x minus 5. If we added 5 to one side of the equal sign, we have to add 5 to the other side of the equal sign. So I'm going to put plus 5 over there on top of the 3. And so if we add together that 5 and that 3, I'm doing that as kind of like a bracket to pull them together. That gives us 8. So in this case, x would equal 8. So it's a pretty simple concept. It can get complicated when you're doing multiple different operations. And the trickiest part about algebra is just making sure you get all the steps in. But the biggest things you need to remember is you do the opposite operation, and what you do to one side, you have to do to the other. Opposite and equal. Okay, we good on that? Let's actually start doing it. All right, so I believe on Classroom, I have a link to this worksheet. Let me make sure. It should be solving equations. Come on, internet. Yes. Okay. If you go to the Google Classroom, you can find this worksheet that I'm looking at. We're only going to do the first page of it, or maybe the first two. Yeah, just the first page of it. The second page gets into 2 variables, an x and a y, and we'll go over that next week. But if you want to pull it up, it's the very last link, the one that says Scotland. It's like glowscotland.org.uk. If you want to pull it up on your own. So I'm not sure how big this is on your screen, but about the best I could do for today. All right, so y'all ready to jump in? Okay, so the first problem is x plus 3 equals 9. I'm going to write it a little bit bigger. So let's identify the parts first. So what is going to be my variable in this one?
You saying what x is for?
Mm-hmm. Yeah, well, what's the variable? And that's the x, right? So this is my variable. And then as far as the operations, so far we're doing addition. So how are we going to get that x by itself?
Can you repeat that question?
How are we going to get the x by itself? That's the goal when you're solving an equation, is to isolate the variable. So if we have x plus 3, what do we have to do with that positive 3 to get rid of it? If you have 3 of something and you don't want 3 of something, you take it away, right?
Oh, yeah, subtract.
That's it. So you're just going to do the opposite operation. So x minus 3, 9 minus 3, because if I do it to one side, I want to do it to the other. So these two cancel each other out because you've got 3 of something and then you take away 3 of something. That leaves you with nothing. And then this one, 9 minus 3 is 6. So in this case, x is going to be 6. Now to double check it, we would just plug that 6 in the place of the x. 6 plus 3, does that give me 9? 6, 7, 8, 9. Yes, it does. All right. Let me do the second one for you, talk through it, and then I'm going to get one of you to talk me through it. Tell me how you're going to do C. All right, so I've got x plus 7 equals 20 as my equation. My variable is x. That's the number that I don't know and I'm trying to answer for. If I have to add 7 to get 20, to get the x by itself, I have to take away 7. And if I do it to one side, I have to do it to the other. So take away 7 there. Those two cancel out. 20 minus 7 is 13. So x is going to equal 13 in that one. And I know nobody ever wants to, talk everybody through these problems, but I'm a little bit of a nerd and I like brain science and things like that. And I have a master's degree that's actually in the theory behind teaching. And you remember about 5% of what you hear, about 20% of what you read, but you remember almost 90% of what you actually teach somebody else. So if you can tell me how to do these steps, you're going to be more likely to remember it. So let's see. Who would like to talk me through C? It says x plus 5 equals 8. So pretend
See,
I've
I know
never
the answer, but I don't know how to get the answer.
see, and that's that's good and bad. It's good because you know the answer. The bad part is well, not necessarily bad, but knowing the steps, you're going to be able to implement it stronger when you get to some of those more complex ones. Yeah, because this one you can just look at it and it's like, well, duh. But knowing the steps is going to help you as we get to the more complex questions. So, can somebody help her out? She and I are both confused. I've never seen letters in a math problem before. What the heck do I do?
So under that 5, you're gonna subtract 5. And under that 8, you're gonna subtract 5
Okay, why?
to get the I don't know exactly why, I just know that's how I'm finna figure out my expression.
Can anybody tell me why? She's right. You're absolutely right. You do. So how do I solve for a letter? What do I have to do with that letter?
Oh yeah, you're trying to get the variable by itself.
Yeah, that's it. Exactly. Okay, so I'm trying to get it by itself. So I need the x on one side of the equal sign and nothing else on that same side. So if I've got that x over here on one side, I want to get rid of everything else that's on it. And you're absolutely right. If I got plus 5, the only way to get rid of something is to do the opposite of it. So I do subtract 5. And if you do it to one side, you got to do it to the other. So what's my answer?
3.
3. Yeah. And that one, just if you ignore the variable, I mean, you can pretty much just fill in the blank. It's basic addition. But again, it's those steps. Because once we get into that multiplication and division, you're going to use the exact same steps. It's just a different operation. Okay. So with that in mind, it's the exact same thing again. Let's look at D. X plus 9 equals 9. What do I do in Y?
Subtract 9 from 9, but That X is 0, I think.
Okay. So we think X is 0. We're working it backwards, but that's okay because on the GED.
Yeah, that's I don't know. That's how I get my answer.
No, I mean that's another strategy. That's when you're taking the GED itself, it's multiple choice for the most part. On those multiple choice ones, if you are pretty sure you know what the answer is already, you can just plug it in and double check yourself. So that's actually a good test taking strategy for speed purposes. But just because we're taking a little extra time and doing the lessons, that's why I'm wanting to get those other steps. All right, so X is 0, we think. And you said you think you get it by subtracting 9 from that side and subtracting 9 from that side. And that would cancel these out. That would give you 0 on that side. So that is the correct answer. Just keep in mind that you got to get that X by itself on one side, the equal sign, and that's why. Because later on, we're going to have problems where there's 2 or 3 X's, and your goal is still just to get the X by itself on one side.
Okay.
All right. I think we get that concept. So we're going to skip E and F because it's the same thing. Let's go to subtraction. It's again still the same thing, but different operation. So G here. Let's see, am I in the screen? I need to move it up some. Okay. G says X minus 15 equals 0. Sierra, I hadn't heard from you much. What am I going to do?
Is it the same concept as the other one?
It's exactly the same concept. So what am I trying to do to solve it? Excuse me.
Okay, subtract 15 from 15 and wait. Oh no.
I love how you said, oh, wait, because you caught it. What'd you catch?
The 0. So you
Well,
got to turn that 15 negative.
it's already negative because it's got a minus.
Okay.
So if I'm missing 15 and I want to have 0, what do I have to do?
Put another negative 15. Oh, add.
Yes. Because think of it this way. If I owe somebody $15 and I don't want to owe anybody anything, I'm going to have to pay, right? So I have to put forth a positive. So in this one, I love how I heard the wheels turning in your head as you figured that out. You got it. So we're getting the X by itself. So we'd have to add 15 to do the opposite of subtraction. So if we do that here, what do I do over on the other side?
I'm sorry, can you repeat that?
Sure. If I added 15 on one side of the equal sign, what do I do on the other side with that 0?
Add again.
Absolutely. Okay, so the positive and the negative cancels each other out. 0 plus 15 is 15. I've got the X by itself. I'm done. See, it's not too bad, huh? All right. H is going to be about the same thing. I've got X minus 50 equals 40. What's my goal to find out what the X represents?
Subtract 50 from 40 and 50.
I'll take 50 away from 50. That's going to give me negative.
No, that's a negative 50. So add 50. I don't know.
Yes, no, you're right. You always do the opposite. So if there's a minus inside of it, in front of it, sorry, then you plus it. If there's a plus in front of it, then you're going to minus it. If there's a division symbol in front of it, you're going to multiply. If there's a multiplication symbol in front of it, you're going to divide. It's always the opposite. So in this case, if I want to get that negative 50 away or the minus 50, the opposite is plus. So I'm doing plus 50. And if I do it to one side, I do it to the other side. Plus 50. Oops, no equal, sorry. Those two would cancel out. 40 plus 50 would be X equals 90.
Okay, I didn't get that answer.
You did or did not?
I didn't.
Okay, tell me what you did.
I subtracted 50 and 40.
Okay.
instead
So
of like adding.
okay. So you had the negative 50 over here. The opposite of that is positive. And so
Yeah,
if
I
you're,
ain't looked at that. I ain't look at that as negative. I added.
I got you. I see. Yeah. So if you add 50 on one side, you got to make sure that you add the 50 on the other. What you do to one, you got to do to the other. No swapping up.
So wait, was that a negative 50? Or is it just minus
Well,
50?
both. So if you have subtraction, it's almost like saying plus a negative. But there's an invisible positive one in front of every number. Every number is like the positive one times that number. And then if it's subtraction, it's like you're multiplying it by a negative one. And that gets big into math theory, and that's beyond what my English brain really likes to think about. But the short answer is if it's got a minus sign in front of it, think of it as negative, and think of the plus sign as positive. And so that way, either way they phrase it, it's going to be the same thing. Minus is negative, plus is positive. So you are subtracting, yes, but it's also negative 50. You're just adding negative 50. Does that make sense? At all?
Yes, ma'am, I get it.
Okay, for right now, let's just think about the symbol, and what you're going to do is the opposite of the symbol. So let's look at K here. Let me hold this down. Well, J and K. We'll do J and K. All right, so J, get up here where y'all can see it. J says X minus 5 equals 0. Okay, so I'm trying to get that X by itself, right? So what symbol do I have in front of the 5? And there's 2 right answers.
You got the X and the X and the negative 5 in front of it. So with that, you're gonna add 5 to both sides.
Mm-hmm. You got it. So it's a minus
X,
5. I'm sorry. I didn't mean
oh
to
my
cut you off.
bad. X equals.
Okay. Yeah, it's going to be equal positive 5. So if you've got a minus symbol, a negative symbol, what you're going to do is the opposite. So you need a positive plus. So we're going to do plus 5 and plus, I keep putting an equal sign, and a plus 5. So that gives us X equals 5. Now K, again, is X plus 11. I'm trying to get the X by itself. So I'm looking at the symbol that's in front of the number that's with it. So it's a plus sign. So what do I need to do? What's the opposite of plus?
Subtracting.
Correct. So I'm going to subtract 11 from that side. And if I subtract 11 from one side, I got to do the same thing to the other side. Those two cancel out. So 0 minus 11. If you have nothing and then you lose 11 more, then you're in the hole for 11, right? So that'd be a negative 11. One mistake I don't want you to make when you're doing subtraction, don't automatically put the bigger number first, because that's not always how it's going to work out. So this one, you start with 0 and you're taking 11 away from that 0. So your answer is going to be negative. It's just another one of those little details to pay attention to. Okay, we're feeling okay on that concept?
Yeah.
Okay, well, let's move on to multiplication and division. The good news is it's the exact same thing. We're just multiplying and dividing. So I'm going to go down to the second section. And if you want some extra practice with this, you can try working out the ones that we are not doing in class. And like I normally do, I included the answers at the end of it. So you can check yourself. And if you don't get the answer that it says on the worksheet, then you'll know that you made a mistake. You can go back and try to figure out what went wrong. Okay, so looking at A down here, and I know that's kind of tiny. It's got a 2 and an X right next to each other equals 18. Now, when we went over when we went over order of operations last week, we talked about what it means when a letter and a number are smushed up next to each other. Do you remember what operation that represents? Is it addition, subtraction, multiplication, or division?
Multiply.
Multiply.
That's it. Thank you, ma'am. I appreciate it. All right. So the 2x is going to be 2 times x equals 18. So if I'm trying to get rid of a multiplied 2, what's the opposite of multiplication?
Division.
Correct. So I'm going to just draw a line and put a 2 underneath it because that's one of the symbols for division. I could also put a division symbol. This is just what I've gotten used to doing. And if I'm going to do that to one side of the equal sign, I've got to do it to the other. The 2 2's cancel each other out. Now notice on multiplication, I didn't have to make it negative to get rid of it. I'm just dividing. I don't have to worry about the positive and the negative. But if it was a -2, I'd divide by -2. The numbers are staying the same.
You want to get a picture real quick?
18 divided
X
by 2.
equals
X equals, what's 18 divided by 2?
8.
No, check your math. 8 and 8 is 16. You're
9.
close. 9. It's going to be 9. And that's something that I'd encourage you to do. I'll be honest with you. I'm 40. I have a master's degree. I still don't know all of my multiplication facts. I just haven't memorized all of them, but it will speed up your taking the test time. It'll help you out on some of these shorter questions. I'm having to redo my meet. Hold on. Okay. And flip the camera around. So I'll put a multiplication chart for you somewhere so that you can maybe make some flashcards or just study those, because if you can memorize them, it'll help. All right. All right, let me log back into this real quick. It was great. Why not? Okay. 479. Sorry about this, guys. Like I said, I'm getting a webcam hopefully tomorrow. So next week I wanted to do this, but for now I'm having to kind of bootleg do it. Okay. Number 4. Yes. Come on, computer. Try it one more time. Okay, now I'm in. All right. If you have the worksheet pulled up, I want to go to letter B on that second section. Let me. Okay, sorry about that. All right, it says 5t equals 30. Now notice in this case, it's not an x, but that doesn't matter. The letters are just placeholders. So all you have to worry about is solving for it. So if I've got a 5 and a t right next to each other, that means it's doing multiplication. So I want to divide. So if it's 5t equals 30, I'm going to divide one side by 5. What am I going to do to the 30? also divide by 5. So the 5 on this side on the top is going to cancel out the 1 on the bottom. And this one, how many times can 5 go into 30?
6.
Correct. So my answer is going to be 6 on that one. Right. And again, with division, if you know your multiplication facts, then the answers are going to help you to know how to do it backwards too. Like, if you know that 6 times 5 is 30, then if it's 30 divided by 5, it's going to be 6. If it's 30 divided by 6, it's going to be 5. And when you memorize them, it just pops in your head, kind of like earlier when Naya was saying, I don't even have to think about it. I just know the answer. The same thing will happen on these multiplication and division ones. And Ms. Robinson, I know you said that that's what gives you some issues. I'm not a big fan of memorization, but it will help on this kind of stuff. All right. One more like this, and then we'll go to division. 3D equals 12. What am I going to do? I'm going to do the same thing I have been doing. And if it's multiplying that 3 times that D, I'm going to divide it by 3. So I'm canceling those out. If I do it to one side, I got to do the same thing to the other. Got to be fair and equal. And so I'm left with D equals 12 divided by 3, 3, 6, 9, 12. It can go in 4 times. So my answer is going to be 4. All right, ready for some division? Okay. Oh, do I even have any division problems on here? Never mind, I don't have any division problems on here. So there's a mixture view at the bottom. Do you guys have this sheet? Have you pulled it up on your... Okay. Let's just do a few of these because they're the 2 steps. This is adding one more level of difficulty to it, but it's still going to be the same thing that we're trying to do. Get that X by itself. So this is closer to what you're going to see on the GED. A says 3x plus 1 equals 13. So this is basically just taking what we did in that first section and what we did in that second section and putting it together. So you want to start with the number that's by itself. So over here, the x and the 3 are attached to each other, right? So I'm going to start with this 1. So how am I going to get rid of this 1? If it's addition, I'm going to subtract it.
So you're gonna subtract this. What I was gonna say.
Yes. But here's the part that you've got to remember. If I'm doing it over here to get rid of it, I've got to do it to the other side. So I'm going to subtract 1 from there. And this is where I highly recommend for these multi-step problems, rewriting your equation. So those 2 have canceled each other out. I'm subtracting 1 from the 13. So I'm going to drop down the 3x, drop down my equal sign, and the 13 minus 1 gives me 12. So I basically just took that larger equation and turned it into one of the smaller equations like we did in that second section. And so now I've got 3 times x. If it's multiplying those 2, I want to do the opposite operation. So I'm going to divide. And if I do it to one side, I got to do it to the other. So these 2 cancel each other out. And I'm left with x equals 3, 6, 9, 12. That'd be 4. So even though it's got an extra step, do you see how it's the same process?
So we ignore the number that's in front of the X.
For the first step. So let me do B and I'll kind of talk you through it again. So B is 4x plus 3 equals 23. So it's kind of the same. You've got a number attached to a letter. You've got an operation plus addition and a number that's by itself. And then you've got what it equals. So my goal is to isolate that X to get it by itself. So I'm going to basically do PEMDAS but backwards. You want to start with the number that's by itself. So yeah, I'm going to leave the 4x alone for right now. I'll take care of that in the next step. And I want to get rid of that 3. So if it's a plus 3, I'm going to subtract 3 from that side so that those two cancel out. But if I subtract 3 from one side, I have to keep that equation equal. I have to keep them, similar sizes, similar ratios. And so I'm going to subtract 3 from this side too. And just so I don't get confused and I don't forget to do a step, I'm going to take that 4x and just drop it down and rewrite my equation. That's canceled out, so I don't have to worry about it. Equals. And then 23, take away 3, leaves me with 20. Now, this is where I'm going to deal with that 4 in front of the X to answer your question. We do ignore it for the first step, but then we come back and handle it. So if it's 4 times X,
So
I need-
so X equals 5.
absolutely, because I'm dividing both sides by 4. You're getting it. I got you. All right. Do y'all want to do some more as just examples, or you think you pretty much got it?
I got it.
Okay. So I know it's kind of the same thing over and over and over and over again, but that's the basic or the basis of algebra. If you get that basic concept, then it's going to help you as you go along with those other steps. If you miss that basic concept, it's going to mess up the rest of the process. All right. So I'm going to stop with that page. Again, it's there if you want to do some extra practice. Let's do the same thing, same concept, but review the word problem aspect of it, because you will see some questions on the GED where it's just straight equations, but they're going to have quite a few word problems mixed in there too. So I want to do a little review on the terminology. So let me zoom in some because I did not give you guys this page. Okay. So
yeah, I was gonna ask if you
if
gave
you
us
have-
that page because I've been printing them out so I could do the work, go back over it and stuff. And I was wondering if we had that one too, but you just said you'd give it to us.
yeah, no, not this one, because it's a whole packet and I couldn't split it up. I'll try to get it scanned in so it's individual pages, but this was just review from last week.
Okay.
Anyway, so if you have, let me start up here with number 1. Okay, so number 1 says 3 more than 10. So what are your keywords there that let you know what operation to do?
More than.
And if it's more than, what operation are you going to use?
Multiply.
Multiplying is taking the sorry, I'm sorry about it bouncing. I'm trying to fix the camera. So yeah, add. Yeah, if it's more, then it's going to be addition. Multiplied is going to be like each, or it'll say per, or for every, words like that. But if it's just more than, less than, that's going to be just basic addition, subtraction. So 3 more than 10, you're going to start with that 10 because that's your starting point. And if you want to know what 3 more than 10 is, you're going to add the 3. So to turn those words in a word problem into numbers, it would just be 10 plus 3.
So you would just turn it around, basically.
Yeah. And I mean, in addition, you have 10 plus 3 or 3 plus 10. It gives you the exact same thing. But if you kind of visualize what this is saying, 3 more than 10. So you have to start at 10 and then count 11, 12, 13, right? 10's your starting point. And so that's why I would suggest putting the 10 first and then putting the plus 3. Because once you get into like multiplication, division, it's going to be really important which number comes first. Same thing with subtraction. Like, okay, number 2. This one says the opposite, less than. So I'm going to do subtraction, right? Because less is subtracting. But what number do I put first? If it's less than 5 less than 8. What number am I going to start with and then count backwards?
You start with 8.
You start with 8. So I'm going to put 8 at the beginning of my equation. And then I'm going to put minus 5. So even though in the word problem, the 5 comes first, when we write it out as an equation, it comes second. Okay. Number 3, 2 times 3. That one's pretty self-explanatory. We just turn it into a multiplication symbol. 2 times 3. Why did that not write? It's just being slow. Is it being slow on yours?
Yes, ma'am.
Okay, I was going to say, that's kind of weird to watch myself write something well after I've already written it. Okay. Now, number 4, this is going to get into those 2-step ones. So you have to picture it in your head almost. 2 less than 3 times 4. So let's start with multiplication, like the PEMDAS, the order of operations. So what's being multiplied here? There's a word in this equation that lets you know that it's going to be multiplication. Which one of those words has to do with multiplication? Okay, I don't know if y'all aren't answering or if I can't hear you, so I'm just going to kind of keep trucking.
I'm
So-
sorry. I keep forgetting my microphone off. I just be talking out
Oh,
loud.
okay. That's all right.
The times is the multiplication. So you gotta do 3 times 4. And then on the first part, you're gonna do 3 subtract 2.
2 less than 3 times 4. This one, it's 2 less than 3 times 4. Ooh, you know what? That one's actually not quite clear, and that could give you 2 different answers. 2 less than, I'm reading it as 2 less than 3 times 4. So like you said, the 3 is going to multiply by 4. So
Yeah.
I would do 3
So
times
you're gonna
4.
The back half first, and then you do the front half.
And then I would put in parentheses. And if
Yeah.
it's 2 less than, you're going to subtract 2.
And that's
You're
gonna
right.
be 1.
It also actually could be 2 less than 3 times 4, which would be 3 minus 2 times 4. Depending on if there was parentheses or not, then that would be 2 totally different answers. But you got the operations correct. I'm not sure which way they wanted it, honestly.
Basically, I don't.
All right, 3 more than n. This is throwing in a variable. So what's it going to look like? It's basically going to be number 1, but instead of having 10, it's going to have an n. So that one I would just write n or lowercase n, either way, more than plus 3. 5 less than n is going to be the same thing as number 2, but instead of a number 8, I'm going to put a letter n. N minus 5, because it's 5 less than n. Number 7, 2 times n. Now, when you throw in a variable, you do not have to use the multiplication symbol. You can, but you don't have to. I can just put 2n or 2 lowercase n, and it still means multiplication. And then 2 less than 3 times n. In this case, I would just put 3n minus 2. So that's to show you that even though it's words and even though it throws in a variable, you're still doing the same operations. You're still attacking them the same way. Okay. I'm going to skip that next section because it's basically the same thing. Okay, so let's do a couple practice word problems that are going to use these same formulas. Get it lined up. Okay. So let's say we're trying to figure out somebody's age, and it gives us a little bit of information, but not enough to know. Not without having to do some math. So number 21, it says Malcolm is 7 years older than Timmy. So let's see, using the variable. We're just writing the equation on this one. It doesn't give us an age or a number. We're just wanting to know what the equation would look like. So if we have Malcolm is 7 years older than Timmy, I'm going to put, who's the youngest one?
Timmy.
Timmy. So let's use a T to represent that. So I'm going to put T for Timmy. And then I'm going to say that Malcolm is 7 years older. So if I add 7 years to it, plus 7, then that's going to give me Malcolm's age. So I'll represent him with an M. Now, in this case, there's two variables, but, you know, they could be kids, they could be teenagers, they could be in their mid-50s. We don't know. But this is what the equation would look like. It's just to show that the letters represent unknown numbers. Is that making sense? Let me back the camera off so I'm not bouncing it so bad. All right. Number 22, it's going to be the same kind of thing. Mally is 4 years younger than Tammy. So whose age are we probably going to know if it's telling us Mally is 4 years younger than Tammy? Who's do we need to start with? Who's got who's older?
Tammy.
Okay. So again, we'll represent her with a T. Okay. And then if Mally is 4 years younger, what am I going to have to do to figure out Mally's age?
Oh, -4.
That's it. And then number 23, Mark is 4 times older than Nathan. So we're going to start with Nathan's age. And if Mark is 4 times older, then I'm just going to put a 4 in front of it because I would multiply whatever that age is. Now, some of the questions on the GED will actually ask you it won't ask you to solve a problem. It'll just ask you to create an equation like we're doing right now. They'll be a little bit more complicated than this. But again, if you have the basics, it helps you when you get into those more difficult problems. All right.
Is there any way to like maybe email me like these 2 pages so I have to go over? Because like I like to be able to go back and check because, you know, I have text anxiety bad.
Sure. Yeah, I have the link to it. Thank you.
Thank you.
So I'll send it to you, and I'll try to just break it down to where it's just those couple pages that we're going over today. It's a whole packet. That's the only reason I didn't put the link.
Thank you.
All right. You're welcome. All right. So 24, 25, 26 are basically the same thing. Let's look at 27. This one brings in one of those 2 steps, which is fun when it's a dance, but not so fun when it's math. All right. Randy is 2 years younger than 4 times Billy's age. These are the ones that kind of start sounding like, wah. So let's start where we were. If it says younger than, we probably want to start with whoever's older. So who is going to be the older one? Or tell you what, let's not even worry about the younger and older. So let's just write it out this way first. Randy is going to be 2 years younger than.
You said that R equals, no. I thought it was R -2 equals 4 plus, I don't know.
Okay, yeah, these get confusing, and they like to give you this kind on the GD. So here's how I tackle it. I just take it in order of what it gives me. So Randy is. So the is going to be my equal sign. That's why I put that there. 2 years younger than. So if it's got words younger than, what operation do I have to do?
Subtract.
But it's going to come at the end, right? So I'm going to leave myself a space and I'm going to put -2 right here, because once I find out whatever this is at the end of the statement, I'm going to subtract 2 from it because it's 2 years younger than. So now I figure out what goes in this blank space. So it says then 4 times Billy's age. So how am I going to represent 4 times Billy?
4x minus 2.
Yeah, 4x, 4b, 4n, whatever, some variable. So that's my equation. So it's a simple equation, but it's the wording and just making sure you get things in the right order that can get confusing. So let's try that same concept for 28. It says Vincent is 3 years older than 2 times Billy's age. So let's take it in order. Who are we going to put first? Or let me back it up a step. Where do you see the word is? Because is going to be my equal sign.
V equals.
V equals, yep. All right. So the next section of it, 3 years older than. So what does that tell me I'm going to have to do?
Add.
And since it's addition, I could go ahead and put 3 plus. I could put it at the end, or I can just go ahead and put 3 plus. All right. And the last chunk of it, 2 times Billy's age. So how could I represent that last statement?
2x.
That's it. I like how you're saying that with confidence. It's like, this is really starting to get easy. All right. Let's see. Last one. Dathan is 5 years younger than 7 times, what's that say? Jamie's age. So where's my equal sign?
D equals 5 plus 2x. 7x.
Okay. So we know we got 7x because it's 7 times Jamie's age. We got a 7x. And
5 minus.
So 5 minus. So if I do it this way, 5 minus 7x, then that's telling me Dathan is 5 minus 7 times x. So is he 5 years old minus 7 times however old Jamie is?
No.
It's backwards from that. So when it's subtraction, it gets a little tricky sometimes. That's when I said that the order matters. So let's scratch that and go back to Dathan is. We got that. D equals. There is definitely a 7x. It's just what comes first, what comes second. So if it says 5 years younger than, if it's younger than something, you're having to take it away from this last part, right? So I'm going to put that -5 at the end of the equation. Because if it's 5 years younger than this amount, I've got to take away from that amount. So D equals 7x minus 5. And I guarantee you, because like I said last time, mathematicians are assholes. The test makers are assholes. So they're going to give you D equals 5 minus 7x is one of the answer choices. And they're also going to give you D equals 7x minus 5 just to see if you paid attention to the details of what goes where. Those dirty mathematicians. All right. Let's see. Let's try this last one just for one more example. I've got a little quiz that I want you guys to do for homework. You've got all the way until Friday to do it. But it goes over these same kind of concepts. And I just want to see, I know it's kind of awkward answering questions in a group setting via the internet. In a classroom setting, you can feed off of each other a little bit more. And I can interact with you a little bit more. But this way, if you show your work like I've been doing on the paper, I'll be able to see what you get, what you don't get, if there's any areas that we need to go back over. So on the homework, what I'm asking you to do with the quiz is to first identify the variable. What is it that you're supposed to be finding the answer for? So this one says, I guess I could get the whole thing in the screen, huh? Max is 7 years older than Jill. The sum of their ages is 41. How old are Max and Jill? So my question is, how old are Max and Jill? So I'm trying to solve for Max. I'm trying to solve for Jill. Max is 7 years older than Jill. So what am I going to do with those, with Jill's age and the number 7?
Subtract it. Add
Um,
it. Yeah, subtract.
older than. If it's older than,
Well,
which
add
one
it.
would it be? Yeah. That's it. It's going to be addition. So Max equals Jill's age plus 7. Okay. The sum of their ages is 41. So that means once you take Max's age and then, let me write it this way. Ooh, where you can see it. Okay, think of it this way. If Max plus Jill, their ages together equals 41. Now what I would need to do is plug in for what I know. So I'm trying to get the same letters, just like we did earlier, trying to get the X by itself. We're trying to get one of these, either the M or the J by itself. Now, Max, we don't really have a whole lot of point of reference, except for we know that he's 7 years older than Jill. So here's what I can do on something like this. And this is a GED staple. This is a big kind of question that they ask. You would take that J plus 7 and substitute it for Max. So I'm going to instead put J plus 7 plus J, the Jill, equals 41. So I just took this placeholder up here and filled it in for Max. Now, this is what we're going to get into next week, is what to do when you have two J's. Multiplication is basically like saying how many times you add a number to itself. So I would combine those two by saying 2J, because there's two J's in there. And I would keep that 7 equals 41. And from this point, we know what to do with it. What would we try to get rid of first if I want to actually solve it?
Girl, you lost me at Max and Jill. I don't know what's going on.
Okay. So this one's a complicated one. This one's like a real challenge one. So sometimes it's like putting together a puzzle. You're trying to solve a mystery and you just have some clues. So what I know, let me back the camera off so you can see it a little bit better. Okay, it says Max is Jill's age plus 7. We got that part from what we were doing earlier, right? Okay. Jill, we have no idea how old she is. We don't have any point of reference. We don't know what to do with it. But I was told in the next part of that problem that Max, however old he is, plus Jill's age is going to give me a sum, meaning equals, of 41. So Jill, since we don't know anything about her, we can't really do anything. But we know that Max is 7 years older than Jill. So if Max equals J plus 7, then that means I can get rid of the word Max. Oops, sorry. And I can just insert J plus 7 because they're the exact same thing. It's like, placing Sean Combs for P. Diddy for, et cetera. It's the same thing, right? Just different terms. So this is putting Max's age in different terms. So J plus 7 plus J equals 41 is now my equation that I'm going to work with, because I always want to get a variable by itself. And at least now I'm not dealing with J's and M's. I've just got J's. So I could combine those two J's together. And this is what I haven't taught you yet. We're going to go over next week. This is just a preview. And that'll give you 2J. I drop down that 7 because it doesn't have a letter with it, equals 41. And now we've got an equation like we've been dealing with. So if we're trying to get that J by itself, we want to deal with the number that's not attached to it first. So how am I going to get rid of that 7?
If we're gonna subtract the 7 from the 7 and subtract the 7 from the 41.
We absolutely are.
Okay.
Sorry, my boyfriend walked in and was distracting me, and I will not tell you how. All right. 41 divided by 7. Ooh, I don't know that one off the top of my head, honestly. Let's see. 7 says 14, 28. 56 would be 4. 21 is 3. Oh no. Somebody that knows math 7 timetables, help me out. Let's see. 7 and 2 is 14. 4
Hold
would
on, you
be,
said 41 divided by 7?
yeah.
5.857, a whole bunch of numbers. What?
Yeah,
I'm
that's
used-
okay. So that one, they must not have. Did I write the number down wrong? No. Okay. They just gave you a bad number. A question like this on the GED wouldn't come out to a decimal. But let's just go with
'Cause
the closest.
we usually round it out, right? To the nearest number, or that's not the same situation.
I mean, this one there's an error in the question because you can't be a portion of a year old. But so yeah, so 5 would be 35. That's close as we can get. Let's round it up to and just pretend it's a 6. Let's go with a 6. Because you can't be less than 5 years old, but you can, if you're 5, you're 5, and then it just keeps adding, right? You can't go backwards. So let's just round up and go 6.
Well,
and
you know
that
how
way-
they do birthdays, so he would be 5 years old, 0.8 months.
Exactly. Yeah. 5 years and 8 months. But you're not going to be like 5 years, not quite 8 months. You know, you don't have unbirthdays. So if we're going to try to get that J by itself now, it's 2 times J. So I'd have to divide by the 2. And that would give me J equals 3. So how old is Jill? If J equals 3, J represents Jill. She's just a wee little thing. How old's Jill? She's 3. Now, this is where they'll mess you up on the GED because the question asks how old are Max and Jill. Well, right now, who do we know how old they are? Just Jill. So to get the whole amount of this question right, I also have to figure out how old Max is. But all I got to do now, since I know Jill is 3, I take that J and substitute it with a 3. 3 plus 7, 7, 8, 9, 10. Max is 10. Now, that's a lot for one little math problem, but this is the kind of stuff that you're going to have on there. And if you kind of get used to thinking in these multi-step problems, then it's going to make it easier. All right. Y'all ready to do a little bit of language arts and get rid of this math? Just a little bit. Yeah, I know. All right. So for homework, I do want you to do a quiz. It's going to be some word problems that include variables, and they are going to be the multi-step ones. So I'm going to post it right now on our Google Classroom. Let me pull that up, and I'll share this tab. Got it in draft. Let me make it go live. Okay. So I just posted it. So if you go to Google Classroom, it should be there. It says homework is quiz number 1. I'm going to read the directions. I know you can read, but I'm still just want to make sure everybody's clear on it. I said either print so you can copy and paste, or you can actually physically handwrite the following 4 questions. For each question, I want you to underline the important information. So we've talked the other day about word problems and how sometimes they give you extra information that you don't need just to distract you. Like that problem that said, how much money does he have for left over from his birthday money? And it included the fact that he had 8 movie tickets that didn't have anything to do with anything. So underline the important information that you need. You're going to create an equation like we were just doing with the variables, an N or an X or something that represents whatever it is you're trying to answer for. And then you're going to solve to find the answer. And what I want to make sure that you do, please, 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 is like I have been doing, and show your work. Show me each step that you do. So that way, if you get the wrong answer, I'll be able to figure out where the problem is so we can go back and backtrack. Let's see, I did include a little video about linear equations. That's what we've been working on, is linear equations. And so if maybe the way I explained it didn't quite click, maybe the way that this person explained it will. Because different people learn in different ways. It's the same concept, just maybe a different way of wording it. All right. Questions or concerns about that homework assignment? Oh, did I finish
No.
put what you did with it?
No, ma'am.
Okay. Good. Now the last
Okay,
piece of information,
so
sorry, I forgot to read this next part. When you finish, text or email me a picture of your completed assignment, if you would. Or if you have a scanner, most people don't have a scanner, but if you do, you can scan it in and email it to me. Otherwise, you can just take a picture of it with your phone and send it to me. And that's how I'm going to be able to look at it, because you can't just come and hand it to me on my desk.
If
Friday
we use
night.
like Microsoft like Word, can't we like send it to you or like do something like that? Like send you like a link to the
that's
Word? Okay.
Sure. Yeah, the only reason I would maybe hesitate to type, well, for these it should be fine, but once we get into some of the things that have like exponents and if we do the division that looks like a little table, there's not any symbol for that in Office that I know of. But yeah, you can type it, you can handwrite it, you can do a combination of the two. I just want to be able to see your work on an individual level. And so that way we don't have to just talk it all out in front of each other, and I'll see individually where everybody is. So everybody's got my phone number because I've texted it to all of you. And my email, you can email it at the classroom address, or you can use my personal email and my personal Sisters of Hope one. I'll text that to you guys in a minute. All right. Language arts, no more math.
So you said yesterday y'all had class. So what days is we having class now? I thought it was just Monday and Wednesday.
Okay, it initially was just going to be Monday and Wednesday, but I was informed that we have to do 6 hours of class a week. So instead of doing 2 3-hour sessions, which is nobody has an attention span that long, including myself,
Oh,
we're doing Monday, Tuesday, Wednesday at 2-hour sessions.
okay.
So that's what, yeah. And I'm not, well, I'm not the one that controls the attendance part, but I personally am advocating to not hold that against anybody because it was a little bit iffy. But yes, our new schedule, Monday, Tuesday, Wednesday, from 6 until 8. And,
Right, because I definitely was not aware of that. That's why I was not on yesterday.
okay, I understand. Let's see. Screenshot. I've been asked to do a screenshot, and I'm not sure how to do that on my computer. Oh, there it is. And got it. Okay, so if you already are in the Google Classroom, if you would click on the handout, let's see, what was the title of it? It's going to be the one that says Colorado Ed Initiative, I believe. Let me double check. Yes, Colorado Ed Initiative. And when you click on it, it should be a chart. Now, this chart, you're not going to have to do anything with it. This is strictly notes. It's already there for you. It's to refer back to. If this were a traditional classroom, I would have this in different posters around my room on the walls so that you'd be able to look at it as you're reading. But these are going to be signal words, keywords that let you know when you're looking at different types of text structures. We talked yesterday a little bit about how there's 2 different types of writing. Well, I guess you could really break it down. No, just do fiction and nonfiction. Fiction is fake. It's made up. It's not based on facts. And then there is nonfiction that is not fake. It's almost backwards from what you would think it would be. And it's real. The majority of the texts that are going to be on the GED are going to be nonfiction. So they're going to be based on facts, or they're going to be what's called functional texts. A functional text is like instructions or a diagram or scientific information, or a recipe, things that you actually use. So you're going to have a combination of those and maybe 1 or 2 of the fiction passages, but mostly they're not going to be telling stories. They're going to be providing information. And one unfortunate thing about informative pieces is unless you just happen to be interested in the topic, it's not going to be very interesting passages. So it might be about butterflies, which yay, butterflies, but it'd be about the migration patterns and why they fly, where they do, when they do, and what their diet consists of, and blah, 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 blah. Not very exciting stuff. So we need to have a plan of attack for the reading, because if your mind is not engaged and interested in what you're reading, it's not going to retain that information. So the first thing I'm going to suggest that you do on the reading section is look at the questions that are asked. When you look at the questions, that gives your mind a purpose for reading, and it's going to be more likely to hold on to the important information and filter out what's not. If you don't have time for that, or you need to go ahead and scan through the text, then another thing that you can do that'll help you out is look for these keywords for text structure, because it'll help you locate information later when you're going back to answer the questions. So this handout shows that there are 5 different text structures, and it gives you the signal words that go along with it. Let me change screens real quick. The first one is description, and that means it's describing something. The author describes a topic by listing characteristics, features, attributes, and examples. It's just telling you about it. Some keywords for that are going to be, for example, characteristics, for instance, such as, is like, including, to illustrate. It's just telling more information about something. And graphic organizers, if you're a kinesthetic learner, if you learn more by doing, or you need to do something with your hands to remember, graphic organizers can help you to make sense of that information instead of just trying to do it all in your head. So the way that this would work is you would put whatever your topic is in that big middle bubble, and then anything that it tells you about it, you would put in the circles on the outside. So if it was talking about a butterfly and just describing a butterfly, you'd put the word butterfly in the middle, and then you might put wings on one, colorful on another, insect on another. So whatever it tells you about in the passage, it would go in those bubbles around it. The next type of text structure is sequence. Sequence has to do with time, and particularly the order that those events happen. Okay, sorry, that was scrolling too much. So it's going to be either numerical, where it's like bullet pointed out, or with numbers, first, second, third, fourth, like a recipe, or it could just tell you chronologically what happened first, second, third. Sometimes it tells you straight out. Sometimes it it'll have the bullet points for the numbers. Sometimes you have to kind of figure out that it's telling a story, a progression from the beginning to end. You've got a list of keywords there. I won't go over all of them, but a graphic organizer you can use for that is just a list. What happened first, second, third, fourth. All right, the next one, get my computer to cooperate, is comparison. And comparison is where you're telling 2 things that are alike. If you're comparing your kids, you're saying he's just like his sister, or she looks just like her brother, is how they're the same. So comparison is the same, contrast is going to be different. With comparison, it's detailing how two or more events are similar. But it can also talk about, with contrast, how they are different. As you've got some keywords that will show you comparison and contrast. However would be contrast. Nevertheless would be contrast. On the other hand, would be contrast. But then similarly would be how they're the same. They're similar. Let's see. Also is another one for how they're like. Same as is another one for how they're alike. But if you start seeing those words repeated over and over again, then in your mind or on your sheet of paper, you can start taking those two things that it's talking about and think, okay, this is something they have in common. This is something that makes them different. And that will help you when you get to the questions, because the questions are going to ask you similarly about similarities and differences. Scrolling down, cause and effect. The hardest part of cause and effect is remembering which word means what. Cause is the reason that something happens, and the effect is what happened as a result of the cause. So cause comes first, effect comes second. You might be able to remember that with alphabetical order. The C comes before the E. So it's when the author presents ideas in a time sequence, but one thing directly leads to the other. I've got a list of words that show the cause and effect, and then this is a graphic organizer that you could use to go along with it. A lot of times there's one event that happens, and then there's multiple effects that happen as a result. So that's why it's split off into the different boxes. All right, let me scroll down. Problem and solution is another one, especially on the science section. You'll run into a lot of problem and solution. It's where the author presents a problem, or in science it's called a, the question, and then you create a hypothesis, and then one or more solutions to the problem. So you'll also see all this on the history section, where it's talking about like political things, where there was an issue in history, and then a president or a world leader or a group of commoners decided to get together and do something about it. So it's a text structure that's not going to just affect your language arts. It's going to also be in the science and the history as well. And it really just helps you to organize the information in your mind so that you can remember it and better answer those questions. All right. So if we want to put this into practice, if you go back to Google Classroom, and this will be the last thing we do today, go to where it says link ERA reading worksheets, the first one. And it has some graphic organizers, and it has some passages. Oh, I need to change over tabs. It should look like this. It's got one page of graphic organizers. It's got a second page that has some little passages. This one you're probably going to want to print to complete, but we can at least do a couple of them together to kind of get an idea how it was done. Let me see if I can do this one more time. All right, so if we're looking at the graphic organizers at the first page, the first one looks like a timeline. And the way that you use a timeline is they go in chronological or sequential order. Let's see if I can write on this one. It'll let me. So you would, nope, it's not going to let me annotate it. Okay, so on that first blank up at the top left-hand corner, you would put whatever happens first. And then that second arrow where there's a blank at the bottom, you would put what happens second, and then, what happens third on the other. The second graphic organizer, this one's going to be comparison contrast, ways are similar, ways are different. The next one is, I can't see that whole screen. Hang on. The next one's going to be sequence. So what happens first, second, third, fourth. Cause and effect, there's going to be two causes that lead to one effect. So one thing happened as a result of two different things. Problem solution, it tells one problem and gives two possible solutions. And then there's another one that's also chronological. So could I get somebody to please read passage 1 for me while I am trying to get this Zoom pulled back up? They aren't going to be difficult passages, I promise.
It says all matters, all things can be changed in two ways, chemically and physically. Both chemical and physical changes are a state of matter. Physical changes are those that cannot change the makeup or the identity of the matter. For example, hold on. It says, for example, clay will bend or flatten if squeezing, but it will stay clay. Changing the shape of the clay is a physical change and does not change the matter's identity. Chemical changes turn the matter into a new kind of matter with different properties. For example, when paper is burnt, it becomes ash and will never be paper again. The difference between them is that physical changes are temporary or only last for a little while, but the chemical changes are permanent, which means they will last forever. Physical and chemical changes both affect the state of matter.
Okay, thank you. So in that one, how many different concepts does it seem to be talking about? Is it just talking about one thing and telling us all about it, or is it talking about more than one thing?
It's talking about two different
To
things.
me,
It's talking about the ways you can change it physically or, chemically.
Okay, so if it's talking about physical and chemical, that's two. So that's going to be a hint right there that it's going to be probably either comparison, contrast, cause and effect, problem solution, because there's more than one thing. And if it's, what is it telling us about the chemical and the physical changes?
Physical change, it'll change. You can change the shape of it, but it won't change what it's made of. Chemical change is like changing completely what something is made of.
Okay, so you just said a key word there, but, and then you told me what one was like, and then what the other one was like, and it's totally different, right? So which one of those text structures would that be if it's telling us how they're different from each other?
Oh, compare and contrast.
That's it. Yep. So find the comparison and contrast graphic organizer. And I'm trying to pull up my phone again. Okay. And we can put in a couple of those details. No, I don't want to use the app. I want to do it in. It won't let me. Okay, well, I can't do it. So if you are looking at the graphic organizers, the one that is for comparison contrast. Oh, goodness. Sorry, I've got stuff popping up on my computer. It's going to be the second one. And what were some of the ways that they were similar that it listed? Some things they have in common. Oh, we already listed some ways that they're different. So you would just go back, look in the text, and fill in some of those specific details about ways that they're similar and different. All right. The second passage. I'm sorry. I'm on the passage and couldn't see that you were about to say something. All right. Let me do two things at once. All right. I'll just read this next passage. Passage 2. So that way I can still have the graphic organizers pulled up. It says, when I got home from school after a long, boring day, I took out the peanut butter, jelly, and bread. After taking the lid off of the jars, I spread the peanut butter on one side of the bread and the jelly on the other, and then I put the two pieces of bread together. After that, I enjoyed it while watching Cops on the TV. I swear that was the best peanut butter and jelly sandwich I ever ate. Okay, kind of a silly little passage, but which one of these text structures would you say that it is?
A sequence.
Chronological.
Yeah, sequence or chronological. And in this one, I would probably lean towards sequence just because it clearly says first I did this, second I did this, third I did this. But really, sequential and chronological are the same thing. All right. So you could either do the first or the last graphic organizer. The first thing that happened was got home from school. Next, took out the peanut butter jelly and bread. I love a good PB&J, by the way. And et cetera, et cetera. All right, passage number 3 says Bobby Fischer. Robert James Fisher was born in Chicago, but unlocked the secrets of chess in a Brooklyn apartment right above a candy store. At the age of 6, he taught himself to play by following the instruction booklet that came with his chessboard. After spending much of his childhood in chess clubs, Fisher said that one day, I just got good. That may be a bit of an understatement. At the age of 13, he won the U.S. Junior Chess Championship, becoming the youngest junior champion ever. At the age of 14, he won the U.S. Championship and became the youngest U.S. champion in history. Fisher would go on to become the world champion of chess, but he would also grow to become his own worst enemy. Instead of defending the title, he forfeited it to the next challenger without even making a move, and the rise of a chess superstar ended with a fizzle. All right, so which one of these text structures would you say that is, and what gave you a clue? Or let's look at it the other way around. What's the topic of this? What is it about? Who or what? This one's going to be about Bobby Fischer, Robert James Fisher, and it's telling about his life. And if it's telling about his life and how he grew up and then became a good chess player,
Cause and effect.
possibly.
That one is chronological, probably.
Okay, so and sometimes there's going to be elements of more than one. So you've got to kind of pull back and see what the whole thing is about. Now there is cause and effect in the very end when it says the rise of a chess superstar ended with a fizzle. The fizzle and not having a very good ending to your career is the effect. The cause was because he forfeited. But is the whole thing about that topic? The whole thing is mostly telling us about his life. And we live in order, right? We're little and then we get older and things happen and then, you're older. So yeah, chronological. You're right, Naya. It's going to be chronological on this one. And that's where it can be kind of tricky is there's some questions on the GED where you're going to need to look at just a small part. And there's going to be other questions where you're going to need to look at the whole. And if it's talking about text structure, you don't want to just look at one piece. You want to look at the text as a whole in its entirety. I'll probably end up giving you a handout or we'll do some notes about which ones you need to look at a small part and which ones you need to look at the whole thing. Passage number 4 says, save the tigers. It says, Dr. Miller doesn't want the tigers to vanish. These majestic beasts are disappearing at an alarming rate. Dr. Miller thinks that we should write to our congresspeople. If we let them know that we demand the preservation of this species, maybe we can make a difference. Dr. Miller also thinks that we should donate to save the tigers. Our donations will help to support and empower those who are fighting the hardest to preserve the tigers. We owe it to our grandchildren to do something. That would be a persuasive text. But we've already used the 2 chronological. We have used the compare and contrast. So cause and effect, problem solution, sequence. Which one do you think fits best? Chronological.
Problem and solution.
Okay, because what's the problem?
The problem is they need to save the tigers.
Yeah, the tigers are disappearing, and what are the solutions? Give money and demand that you save the tigers. And do you see what I mean about these passages not being very interesting? This is the kind of stuff that they're going to have on the GED, that or classic literature. So classic literature is a little bit harder to read, and it's usually really old. And don't tell anybody I told you this, but they just use it because they don't have to pay the rights to use newer stuff. But anyway, that's why they pick classics. But if you know some of these little tricks, it'll help you to just look for the important information and not just start going blah, 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 blah. All right, passage number 5, the Great Recession. So this is a historical piece. Many people are confused about why our economy went to shambles in 2008. The crisis was actually the result of a combination of many complex factors. First, easy credit conditions allowed people who were high risk or unworthy of credit to borrow, and even people who had no income were eligible for large loans. Second, banks would bundle these toxic loans and sell them as packages on the financial market. Third, large insurance firms backed these packages, misrepresenting these high-risk loans as safe investments. Fourth, because of the ease of acquiring credit and the rapid growth in the housing market, people were buying 2 or 3 houses, intending to sell them for more than they paid. All of these factors created bubbles of speculation. These bubbles burst, sending the whole market into a downward spiral, causing employers to lose capital and lay off employees. Consumer spending then plummeted, and most businesses suffered. The economy is like a big boat, and once it gets moving quickly in the wrong direction, it's hard to turn it around. Now, that was a lot of details, but if our purpose for reading was text structure, what are some words that kind of stuck out in your head that, oh, this might be the type of structure that I'm looking at? I know for me, I call it like the first, second, third, fourth. So that kind of makes me think it could be sequential. But then if I look at the details beyond just those words, it was giving me reasons that the Great Recession happened, right? So which one of those text structures has to do with the reason that something happened and the result? Here's my cause and effect one.
Well, benefit, yeah.
Yeah, sorry. We're getting close to time to go, and I think everybody's getting tired. So I'm just going to do the Dora the Explorer thing. Where are we going next? The forest. All right. Passage number 6, screen protector. So that one would go, number 5 would go in the cause and effect. And where it says first, second, third, fourth, those are all the reasons. Those are the causes. The effect was the Great Recession. All right. Last one, I do believe. Oops, do I even have the whole thing? Hang on. Okay, well, I don't even have the whole passage, I don't think, on my copy, but you'll know exactly what the text structure is just by the very first sentence. Before applying the screen protector, clean the surface of your phone screen with a soft cloth. All right, so what is this passage going to be about? Like, what is the purpose of the rest of that paragraph if we had it? It's going to be about how to apply a screen protector. So it's giving instructions. So which one of those would most clearly align with some instructions where you have to do one thing first, then something second, then something third? That one's going to be our one that's yes, thank you. That one's going to be the one that's sequence. So most clearly, that one is sequence because you have to do it in a certain order. Because if you try to apply the screen protector before you take off the protective cover, it's not going to stick. It's important that you do it in the specific order that's got to be the sequence. All right. I'm going to call it for the night. You've got one other sheet that is more practice on text structure. It's for you to read over on the weekend. And it's got some more graphic organizers. You wouldn't have to fill them out, but at least just identify some of those keywords and be able to explain why those different passages are those different text structures. Like, if you say it's chronological, well, why did you tell me it's chronological? What information is being presented in order? So 2 pieces of homework. Do that math that's listed on Classroom and then click on that last link that's in Classroom for today's meeting. And it's going to be Text Structures 2. Looks like this. It's just some more of those short little bitty passages and some practice identifying text structures. So, thanks for sticking in there with me. I know that math was getting a little like, ugh, but you guys were really catching on, and I could tell that you were getting more confident as we went. So I'm proud of you. And do y'all have any questions or concerns before we sign off? All righty. Well, y'all have a good evening. I'll see you on Monday at 6. I know. Sierra, did you want to try to figure out what's going on with your camera? All right, let me stop recording.